All right, welcome back, everyone, to our Open Game Data Open Office Hours. Just want to kick off with the usual introduction before we hand it off to our speaker this week. So the Open Game Data community is this NSF-funded research incubator that has the goal of bringing together a collective of researchers that are interested in using data that's generated from within and around games to better understand how people think, learn, make decisions, and to set up a set of common practices for how to do that kind of work. And so we have two primary goals here. One is to collect these sort of best practices and examples of how to do this work. And then ultimately, our goal will be to build tangible research infrastructure to facilitate this community to work together and understand each other's work. We have a number of Open Game Data resources that already exist. So we have the Open Game Data website that Field Day hosts that lists a bunch of games and provides a bunch of data sets that you could use to do your own Open Game Data work. We have a Slack where we all get together and talk about the ongoing sort of community, and we have these open office hour sessions like the one today, where we use these sort of as a set of working examples on how to do this kind of research. And so how these sessions work is they're inspired by a series of sessions the Statistical Education Research Group used to do at CMU, where students would get some help from a stats faculty in public. So they would present on some work they were doing, and then they would workshop with the stats faculty. And it was super valuable to be an audience member in that group just to see how experts think in context. And so generally, the presenter will get some amount of time to share their work, their game context, and then we'll publicly workshop with them to sort of help them move forward or talk about interesting questions or ideas. Some things to keep in mind, the presenters are usually showing work that is in progress. So please take consideration that can sometimes take courage when things aren't necessarily done and things might be incomplete or not fully developed. Our goal here is to help the presenter understand their own work and achieve their own goals. And the sessions are designed for learning for everybody involved. So if you hear anything that you don't understand or need clarification or something, feel free to raise a hand and ask about it. And with that, I will hand it off to Jen. And I will stop sharing so you can share.
There we go. Trackpad. All right, so let me go ahead and share my screen over here. Okay. So welcome. I know that many people in the community probably already know who I am, but just to introduce myself, I'm Jenn Scianna. I'm a PhD student at UW Madison. I'm in the curriculum and instruction department, but I'm in the subset there. We are studying like design, informal and creative education. So we're the DICE section of curriculum and instruction. And I work with Dr. YJ Kim, and I'm currently calling in from O'Hare. So if there are some like planes or other announcements, just stay with me. We'll get past it. So I thought it would be helpful to think about how did I actually come to this work? And I started as a science teacher where I taught middle and high school science. And a lot of times that meant that I was actually this like pedagogical rebel as I was trying to get students to engage with science. And I was reminded of this when I was trying to find a photo for this slide. And this video popped up of when I was teaching them how instantaneous velocity worked through calculating the speed of racehorses. And so a lot of times as a science teacher who's trying to do new things, that brought me into this world of like, where can I find better tools and things that can help me to work with students? And I often defaulted towards games. So I was one of the teachers who got to pilot Radix Endeavor back in the day. And the more that students were engaging in that platform, I was fascinated with how they were thinking about solving problems, whether they were trying to work with other students or if they were trying to really just explore everything that was in there. And the sheer variety of strategies, I was just like, there's no way that I could think of to have a dashboard that like really can capture all of these pieces. And so I became really interested in the data that comes out of these and how we work with dashboards. And I went back and became a graduate student to kind of try to tackle some of those questions. And in doing that, somehow found myself as a content designer and producer for the game that I'm going to be talking about today, which is Wake, Tales from the Aqua Lab. And so with that, I've kind of circled back now that the game has reached completion, and I get to hang out with kids and actually do play tests. So I can think about, what does it actually mean to be a science teacher? Who is this pedagogical rebel trying to use games in a way that is bringing new types of data that align with this game that I understand really deeply and make sense of kids learning? So with that, I want to kick us off with a question of thinking about, how should kids do science? How should students science? Because often when we think about experimentation as a practice, we think about it as something that's controlled. It's really meticulous and methodical, and we want students to have a hypothesis, and we want them to do multiple trials and understand how they need to be rigorous. But when kids think of science, they often think of things exploding. They want to be like the Adam Savages of the world that are like just doing experiments for the fun of it, and they want to see that like aha moment for themselves. And so how does that actually come together when we start to try to think about what games can do, in that games can give kids autonomy? How do their expectations and our expectations work together in that way? Like, what happens? So in Wake, we have an experimentation mechanic that uses this first entry-level observation tank. And as players move through it, the first thing that they have to do when they start the observation tank is select an environment type. So you can see here, this is like later game. Once they've been to a bunch of places, they can go pick the Rodeo Cove, they can pick the Forested Lagoon, they can choose whatever site they want. The second thing they have to do is actually add in creatures that they're going to observe in that tank. So they can select any number of creatures up to 4. And that was really important during the design of the project, because we were concerned about limiting the players to only 2 because of the implications it had. One of our designers was really invested in the idea of like the traditional view of science experiments, that it should be controlled, that we should only allow players to study one thing next to another. But this allowed for more like emergent interactions, and by proxy reinforced the idea of controlling experiments, because there's an opportunity to actually miss information if one of your creatures gets eaten before you can actually observe the behaviors. So the way that players actually go about observing in these environments is that they're watching for these little emoji to pop up. So you can see the little yummy face emoji here. And as they're kind of watching the species move around the tank, they move their cursor back and forth until they see one of these. And then when they click on it, it's like a little photo mechanic, and it grabs a rule for them, which is stored into the game's system. So how can we actually see this happening in real time? Can we see the times when students are trying to explode things, when they're trying to just set up experiments just to see what might happen? Do they even try to do that at all? That was one of the questions we had, because it is likely that like that is something that they like to do. Like that's why the Coke and Mentos videos all took off. But we don't know that they're actually going to do that. And if they don't, is there actually even any variance at all? In games, they can be really supported in terms of providing scaffolding for students. Are you all still good? Because there's like weird drilling happening. Okay, perfect. So we were wondering, is there even any variance that players can actually like have when they're approaching these different tasks within the game and they're trying to get rules? They might just all go about it the same way because the game might be more on rails than we thought. So how would we even approach these questions was something that I was wrestling with, because aggregate features didn't feel like they were nuanced enough. If we were thinking about things like, well, how many experiments are they doing that have 4 species versus how many times are they controlling the experiments with only 2? And then on the flip side, trying to do something like pattern mining didn't feel free enough. There's so many different combinations of species that they can pick and environments they can pick and ways that they can structure that tank, that it didn't seem like we would be able to capture some of those descriptions and context just doing a pattern mining process. So instead, we needed something that could actually see how players' thinking was developing throughout their play. Maybe we need contextual features of some sort, or just a different approach. So the way that I thought about going about this, I've done a lot of other work using quantitative ethnography, mostly thinking about discourse. The method itself was actually based on the idea of discourse that includes context, where people are talking about practice or talking about something that's relevant to culture. And the thing about the method that is really valuable for this particular question is that it allows for accounting for co-occurrence of if person one is talking about one thing and then person two brings something up, they probably did that for a reason. And that idea of the structure of natural conversations is how we can like kind of think about what QE was really meant for. It also offers this tool of epistemic network analysis that's a highly interpretable visual model. So thinking about that, I kind of broadened the way that QE scholars have traditionally thought about discourse to thinking about players and games as being in conversation. I went through our event logs, tagged each of the event logs from the observation tank for those same behaviors that I've been talking about. So looking at max observations, looking at controlled experiments, looking at moments where the game gives the player feedback that they missed something. So they have a little guide character that if they happen to miss a fact because of either they like walked away from their computer for a few seconds or whatever the case may be, they get this little pop-up that is a dialogue piece that says that they missed something. And then are they getting facts, which you can only get a fact once. So this would help us to understand, are they continuing to run experiments even though they already have that fact? And are they completing tasks? So separating those two out, because you can get a lot of facts just for the fun of it. And you can also do them in connection with finishing actual experiment tasks that are related to your current job. When we do that and create the epistemic network analysis, it's looking across the event log for within a window, how many times do these codes occur together, and creates a matrix that then we use SVD to plot where those positions are in 2 dimensions. And so because I was looking for the most variance, I just left my rotation without any grouping for my initial investigation. And we can start to see where players are grouped based on their connections between these codes. So for example, I think you can see my cursor. Yeah, okay. So over here, we have a bunch of players that are connected between receiving facts and max observations, which makes sense. If you put a bunch of things in the tank, you expect to get a bunch of rules out. They should, if there are interactions, you should be getting something back. The ones that are more interesting is this group up here, where they're controlling observations and completing tasks together. So they have this particular connection here. It's not super strong, but for these players that are most aligned with it or are kind of drawn towards that edge, that is important for them. Also, these players down at the bottom here who have these connections between receiving fact and task experiment kind of shows that these ones in particular are really focused on only doing the work that they absolutely need to do for the job. So again, we can use these axes to better understand just based on the position of each of our users where they are. Yes, Eric.
Can you go back to the slide where you define these 4 things again? Just one more.
Yeah.
Yeah, that, right? So max observations, that's putting all the things in the tank. Controlled experiment, that's just comparing 2 things. So that's like being like CV strategy or control variable. Miss something, so that's Receiving feedback that they missed. So that's like the game detected that they didn't get something.
So the game provided them with feedback that says, hey, you didn't actually see this thing that you should have seen based on how your experiment was constructed.
And was that they didn't snap the picture of the emoji, essentially?
Right, right. And sometimes it's that like I said, so if you put in, for example, otters, urchin, and kelp, you could potentially miss the urchin eat kelp behavior because the otters ate all your urchin.
Okay. But that's like a race condition thing, right?
Yep.
Is it possible that like you set up an experiment and you should see something and it just doesn't happen because the randomness doesn't happen fast enough, or
that
too many things maybe?
Okay.
If you have too many things at the same time, it like, yeah, a species might die out before it ever gets a chance to illustrate some behavior.
Like one urchin and one kelp and they just never get close enough to each other to eat, or is that a thing?
It automatically picks how many are going to be in there. So it like the simulation that's running in the experiment tank is pretty tuned to like be in proportion based on, we used it based on like where you are in the food pyramid. So are you like a primary consumer or a tertiary consumer, and would have like approximately that many species in. So you should be able to see it. And we also did some tuning when the game was still being play tested to make sure that players wouldn't leave the experiment before they started seeing behaviors, because that was problematic. Also something that we'll see in what we're finding.
Got it. So it's pretty likely that the missed something is because of a misconfiguration and not just chance.
Yeah.
And it seems pretty small in your chart.
Yep. Yeah.
Like
it's not of super common code.
Yeah.
It's not something that happens very often.
And then receiving fact, that's just they received it at all. It's not like how many facts they received.
It's every time they receive a fact.
Okay. Yep. Gotcha.
So because it's looking at literally the event log.
Got it.
It's tagging every single line that is that event type of receiving fact is coded as that.
And then experiment task is completing a task.
Yep. Is completing that task, which players might have multiple. So there are some jobs that are heavily scaffolded that have like, find the rule of urchins eat kelp, find the rule of otters eat urchins. And so they might complete each task along the way. Other ones are like, find these 3 rules, and then you're completing one task.
Got it.
All at once.
And so that's irrespective of job necessarily, it's just tasks happened. Cool.
Right.
Great. Cool.
Even in that example though, so that's one of the great things about this is that even if that only shows up of complete task, if it shows up once, but they've completed a bunch of rules just before then, all in the same experiment, we'll still see connections to those 3 rules. So there will still be a strong connection between receive fact and complete task, even though there's a different granularity in what completing a task might look like.
Got it. And then in your window, it's just co-occurrence of these codes. It's not like precedence or anything. Like
right.
Ordering. Cool.
Right. Cool. So I haven't played around yet. There is Yeyu is working on some both multimodal analysis, and also she's been collaborating with the ordered network analysis to actually add precedence and things like that. So multimodal is going to hopefully allow for us to be like weighting certain pieces so that some might take more precedence than others or be more important, and then the ordering having directionality within the data set. But right now I was mostly focused on co-occurrence because it's not just what do you do after, but there is also some, like, even if they're just happening in the same window of, oh, you did this and so you missed something, but you then missed something, like, how does that all kind of play together?
Right. Cool. Thank you.
Yeah. So I think I was just talking a little bit about the like looking at axes. Then one of the things that I did then was to start taking a look at how do players actually like, if we just were to look in one job, for example, and how do they initially approach experimentation? Because I thought that that might give us an idea of what like views they're bringing of how they should exist in this space. So this is just looking at Kelp Welcome, which is the very first job that they do. And again, we kind of see this three groups of folks. So we have the ones who are down here, have this little group up here, and a few folks who are over here really focused on that task completion. And so I picked one of our users, this one way up at the top. And when we look at what was happening with Remote Clef, we can kind of start to understand what on earth they're doing. So they start an experiment, and the very first thing they do is they throw a whole bunch of things in the tank. Immediately end the experiment. And they're like, well, I don't know what that was, but I know I'm supposed to do an experiment, and nothing else happened. So they go back, start a new experiment with just 2 things. Nothing happens, so we end it. Go back, start another experiment. 2 things that are not actually related. Kelp and otters, we're not going to see any interaction. So we're going to end the experiment. And they continue to do this and do just another experiment, just another one, because in the beginning, when they put everything in, it didn't help them move forward. And we kind of see this pattern with a couple of different users in that particular area of the plot. When we have the users down here, they're the ones who are gathering facts with the max observations. They're just getting a whole bunch of things together. Our users over here are gathering facts to complete tasks, fewer of them. Likely at this point, they don't actually understand that that is kind of a desired thing for the game, that that's how you go through and complete things for the game. Up here, again, we have players who are controlling experiments either to address things that they missed, and they're trying to complete tasks, but they're not entirely like successful at it yet. So eventually, once they start to control it, then they start getting that complete tasks, which is why it's a little bit of a lighter connection for them. So what does that actually mean for proficiency, assessment, any of that? One of my colleagues at UW is Mariah, and she had this idea of, well, what if we took students who are challenging themselves? This all kind of came about because I was trying to understand, is there a way to test for variance? So like a statistical test to see, are some of the groups or some of the jobs actually more distributed in terms of how players are doing them than others? And so what we did was actually limited, we dropped out, missed something because like you saw, it wasn't that important. Added a few more grouping variables. So split our players by ones who eventually took on higher challenges, so made it to some job that had an experiment with a level 3 or above, and then our low challenge players who never make it to an experiment level 3. And what's interesting is that the ones who make it are all right here. They're all our players who have this really strong connection between max observations and receiving facts. And our ones who don't, they are like all over the place. So we...
Can I ask you a question about that?
Yeah.
Does that essentially imply that not following control variable strategy is actually more optimal for Wake than following one?
This is a question. This is a question that we currently have, because we're trying to understand why are those ones also compacted? And I have one idea that might be related to the game structure, but the other one, I'll get there. So the one thing that we did look at though is that using this KDE plotting of the players' epistemic networks, we were looking at like the density. And what we're interested in is that in the low challenge groups, we have these kind of subsets that emerge that just help us to see that like even though they're all over the place, there are like pockets that we want to get a better understanding of what do those pockets actually mean. Because we're thinking that some of them are people who are like essentially bouncing, and some of them might be people who are really confused, and some of them might be some other reason that they're doing that. So like your question, like, is that actually, is there value in initially chucking everything into experimentation and just going for the max number of rules? And we don't know, but even in that first job, when we looked at the players who weren't doing that strategy, the ones at the top and the ones who were really task oriented, they don't seem to be the ones who are the most successful. So maybe, but we really have to, one of the things I'm hoping to do is look at that strategy in comparison to some external metrics and understand if there's some correlation there. Like, are they just better at experimenting in general? Do they just understand that this is an optimal strategy? And I'm hoping to have some interviews with students as part of my dissertation work to do that. The first question that actually comes up out of this is just, is this analysis actually useful, or are we just seeing this variance as a feature of later jobs? In some of the later jobs, they just require more rules without necessarily relating to tasks. So it could be that those are skewing the models of those players over to that side, that like players at that point know that they're supposed to get a bunch of rules, so they run max observations anyways, and then they're getting a bunch of rules because the environments are relatively new to them. So it could be that that's part of what's happening there. The other question that comes up is like thinking about how might additional context actually support our analysis. So these were my first run at finding codes and tagging them, in part because I was coming at it from a frame of like epistemic agency and thinking about like what are the different ways that players could set up experiments. But there's other things that we can look at in terms of like exploding behaviors. So mismatches between the system, between like the environment and what species they're using, things like that. And those are things that I'm working on, little scripts to tag those events in the future. Some of this is building, or go ahead.
When you say exploding behavior, do you kind of mean that as like transgressive play, or?
Yeah.
Or is it kind of a mixture, I guess?
It's kind of a mixture. I refer back to like subversive play, because transgressive to me is like making a statement with being subversive in some ways. As opposed to like transgressive play is often trying to like recapture power in some ways, like thinking of Aaron Trammell, and some of that scholarly work. I'm more thinking about smaller bits of subversion where students are like subtly working against the game curriculum and class expectations, but mostly for their own autonomy or for their own interests. So I go back to this example of Lakeland where I had a kid playing this game and they refused to put out a dairy because they just wanted to run it as a vegan society. And that's amazing, and I'm happy for them. Some kids in Wake just they really, really love the turtles. And so they're just gonna put the turtles in the tank with everything to see if they can get all the turtle behaviors. And so like, it is subversive in that it's not what the teacher's asking them to do. It's not what the curriculum's asking them to do. And it's not really moving them forward in the game, but it is for some personal reason. That's not necessarily directly in conflict with the like surrounding structures. So yes, I'm hoping to do more work in like thinking about Wake in that like subversive area. And yeah, that is me. So thinking a lot about play in the classroom and subversive play and how curriculum plays into that. And this method that I don't really know what to call, of some sort of qualitative computation that lives as an offshoot of QE.
Yeah, that was whatever. Do you have I was gonna ask if you had like a name for what it was that we just looked at. Like they're kind of.
So I've been I presented at QE last year about the value in log data as being able to bring this type of analysis and kind of treating it as still as discourse, but coming at it from like a cybernetic lens almost, of people literally being in communication with the technology and thinking about it from that perspective as to why we can still justify this like temporal relationship and why co-occurrence really matters. And sometimes in games that gets tricky thinking about co-occurrence, because you really have to define your window of what, like how quickly, how many actions do you expect to actually relate back? And sometimes players can't actually respond to what the computer is telling them. Like if we use Lakeland as an example, if you don't have money to solve the problem that the game is warning you about, well, you can't actually say anything. You're just getting yelled at, essentially. Which I suppose is still valuable in terms of what we're seeing for connections in the conversation, but it's just different. And you really have to understand the structure of the game and how that conversation is taking place between user and game.
Wouldn't a similar thing happen in like human dialogue? Like, how does QE handle that? Like, is there like a patterning system or something? I guess it's like the whole history of NLP, but is there a system they would use to like define those kinds of rules, or is that kind of what you're doing here? You're making the analog of that.
In terms of the rules, so there are some ways that people have thought about defining the conversation length, is what it's referred to in epistemic network analysis, is that you're basically, there are a couple different ways to think about conversation, but you're segmenting it into what pieces make sense to be connected. So for example, in this analysis, we limited any connections that players were making between their session. So if they stopped playing, picked it up again 2 days later, those, we don't connect anything from one to the next. And we used a window size of 8 because that seemed to allow for enough of the interim decision making without losing any prior context. So even if they're adding things, removing things, adding things, removing things, we're still getting back far enough in the conversation to have the context for what was being said by the computer or by the player.
And that's 8 actions?
Yes.
On the part of the player,
which are filtered actions.
Sure.
I should say that. So we filtered out anything that was just random, like helper text, or anything that was like not relevant to the decisions between the experiment and player.
And that window slides along the whole session.
Mm-hmm.
Did you think about like hard cutting it like by scene, like when they go into the lab scene or whatever, and then like that's a segment as opposed to sliding a window across the whole session?
I did. So part of, I guess part of the reason I didn't actually do that is because I was also interested in like, I had a grand plan of being able to connect between mechanics. And even like, okay, so this is just looking at observation, but there are other experiment tanks. So if they go to the measurement tank and realize they can't get what they need, do they go back to observation, or does their behavior in the observation tank actually inform what happens in measurement? And seeing some of the connections between those two tanks could be really interesting.
Right. It seems like you're kind of going you're trying to go for kind of like the core gameplay loop as opposed to like the sub loops of the individual tanks versus like the macro loop of the overall game. But you could think about potentially doing this, whatever we call it, QE thing, at those different grain sizes of conversation.
Right.
And you would like aggregate in different ways to look at different scales of
Well, and we can also actually even like start to describe the user differently. So here in this analysis, our user, or like our unit rather, is defined by user.
Mhm.
As opposed to in this, our unit is defined by user by level.
Mhm.
So in this one, even though the conversation is long, each unit could connect back to like themselves in a previous job, technically. Unlikely because of how much space is probably between those with argumentation and everything else, but you technically could, especially in job swap situations. But that's why I only have the user plotted as like our key here, but these are just what did this particular user do in kelp welcome.
And since this is also like the first level, it's probably less likely that they would
Right.
transit jobs. So I'm curious, in this plot, you jump around a couple different sections of it. And particularly, I don't know if you have a version of this plot that has all the circles on it, but I noticed like this current pink circle, and then like you highlighted the one at the very peak, like are basically next to each other.
Right.
And how do you decide that, like, how do you, looking at a plot like this, digging into the data, make the qualitative judgment that there is a line there because they look kind of grouped? This is more for like for people who haven't really used this kind of technique before.
Yeah, so one of the reasons that I actually really love this as just a way to visualize things is here. Am I sharing my whole?
We see your whole browser.
Browser, yeah.
Let me jump over here just because I can show you a little bit of my process. So basically what I was doing in the initial steps was using this interactive plot to try to understand like, okay, so this particular user is getting positioned in this place and that means something. Like I said, the way that ENA works is that basically based on the correlation matrix, which looks like this, not like that. Maybe I might not have that one. So, but it looks at what are the actual co-occurrences of codes to one another for each individual unit, and then tries to place those codes on, or place the units on dimensions, maximizing the variance between them. So the units get placed, and then based on that, the codes themselves get placed based on where you would expect them to be. That's why every time there's like, based on where each of these are, where the units are, how strong they have a connection between the codes, where the edges should like visually be, that's how they wind up getting placed with their strengths. And that's why each of the plots has to have a like metric basically for how interpretable is this, like visually is this where you would expect. So we get like co-registration scores essentially on the plots. But as I went through and I started exploring them, I would print out, okay, well, what was actually happening there? And kind of complete that qualitative return to your data, understand, like, is this manifesting the same way that you would expect that edge to actually look? Because I can tell a story about the plot all day, but what does that actually look like when we start to pull up cases? And once you reach saturation of you've read enough of the cases that they seem to all be representing the same thing, then I can start drawing those circles. So that's the like qualitative way of doing it, right? The flip side, the side that sometimes I get pushback when I'm in CRCT, the like Center for, what is it? I always forget what the acronym actually is. Something thinking is that they can technically, each of these points can be fed into like k-means clustering.
Mm-hmm.
They have positions and you can cluster across just the first two dimensions. You can cluster across any that have significance. So in this, if I'm back here, what I mean by significance is that this, for example, SVD1 is explaining 60% of the ish of the variance between my data. My second dimension explains 20%. That likely means that everything from SVD3 and on is very, very, very small.
Okay.
So if I'm going to do any clustering algorithms, I probably don't need to use those. There have been cases where I have a dimension that once I plot it and I look at it, I'm like, oh, that's actually way more significant than I thought it would be, but it's only significant with one code. And sometimes that's an important code, sometimes it's not. In the case when I was looking at ShadowSpect, it actually wound up being a really important code for interpretability. And so we included that in our overall analysis. I don't know if that actually helps answer your question. The short answer is you can do it qualitatively or computationally to draw the circles on the plot.
Right, yeah. Yeah, I guess it does help in kind of clarifying how you kind of dig in and you kind of work with some of this stuff. And I could see ways where like a more custom built plot could be made such that like when you hover over the point, you actually just get the snapshot rather than having to like go between like 3 different pages of a Jupyter notebook. But I was also kind of wondering, like, given that you're seeing there is a line there, is there a way to, I don't necessarily want to say like massage the data, but like structure it so that it becomes more salient in the visualization? Or would you say, like, for the two there that you have, there's the one green circle and then there's that smaller pink circle, are those really actually kind of just very similar to each other and they're just slightly different? Like maybe that green one is kind of a subset of that bigger pink section?
Yeah. So in that case, I would definitely say that my little green dot that I'm highlighting up here, these are just the ones that are like at the most
Right.
extreme of the kind of edges. When you also have a plot that has that clear of edges, one thing to consider is why. Like, why are you getting this kind of bounded effect in there? And that's also a reason why I'm starting to explore other codes, because it's likely that there's something that I'm missing in terms of being able to kind of find the nuance between these players and better understand what they're doing. Sometimes it's that, like, one of the powerful visuals that Mariah has for me is that you have to figure out what angle you're looking at the umbrella from. And based on like, are you actually looking at the top of the umbrella or are you looking at some weird side glance? And then how do you actually get that to move so that you can see the whole thing, right? And so a lot of times that's either by increasing the number of codes or finding a different way to segment data so that it's just more clear what the salient connections are.
I've got a question. I didn't notice this until this conversation, but we use the word code a lot, right? Because ENA, epistemic network analysis is thinking about discourse and it's thinking about like patterns in speech and then the relationship between those patterns, how they are located with each other. But then you've made the leap to thinking about codes within that system as here are just events, right? This is like a raw mapping of event. and are already seeing some interesting insights around how event patterns relate together. And that seems to invite a very iterative approach, which is effectively swap out event for detector and do the same analysis.
Absolutely. I
Yeah.
mean, and you can have things that are detectors by fiat, right? Like by sheer definition, this is what the specific behavior I'm looking for is.
Yeah.
So one example of that would be in ShadowSpect, right? There are certain behaviors that are expected that you have to use, certain tools you have to use to solve each level. If you use a wrong tool, like you can tell that. It's not just that they clicked on the scale, it's that in that particular level, they don't need to scale anything. So we can detect that by definition and code it. But you can have more complex detectors as well that are things like the, well, we even have some of them in Wake that are like idle detectors and things like that, that you can include as well.
The thing that immediately came into my mind is thinking about the whole idea of replay-based training. So thinking of Jody Asbell Clark's work and with Elizabeth Rowe and thinking about like computational thinking codes, where you're like, here's a moment of that, and how would those be sequenced or co-located with each other? And then the other one that came to mind immediately was thinking about some of the work with, because it's a whole bunch of people surrounding Ryan Baker, but all the affect related work. So you're like, if a kid moves from bored to frustrated to engaged, like what are the, I guess I'm thinking kind of sequentially, my brain's really been in the progression world, but like thinking about the relationship between certain ways of thinking and certain ways of feeling as they show up for certain players.
Yeah, one of Ryan's students actually had a, oh, I don't know if they included affect on it or not, but it was using Crystal Island, where they were taking kind of this approach of looking at connecting certain behaviors in the game to also the rooms that the player was entering and how they were moving through the like areas in Crystal Island. And whether that actually correlated with like success or not.
Yeah, I haven't got my head around, I guess, the thing that you haven't named yet, which is epistemic network analysis. This, whatever this part of epistemic network analysis is for game log data and like where that plays out. Like, I feel like you're scratching the tip of something, and I don't know what it is. But this is really different than like a clustering analysis, right? It's got some, because it's thinking about the location of things in the proximities of things being central.
Yeah, so the thing that I'm actually really interested in is, so a lot of times when we're clustering, we're doing that on some sort of feature, right? So it might be a aggregate feature, it might be something like persistent scores, or something like that is kind of universal across gameplay, and we're comparing that, you know, we might have 2, 3 dimensions, however many dimensions we need for features. Edge weights for a given unit are just another feature of the data.
Yeah.
And that's something that I'm intrigued with kind of playing with in terms of thinking about, okay, so we do this type of analysis. We find out that one of the users up here has really small connection weights between receive fact and max observation. They happen to have really strong connections between controlled observation and task experiment. How can that actually help support some of the analyses that we're trying to do in terms of maybe even things like overall proficiency or like struggle detection, things like that, by kind of pulling them out and including them right alongside other level features.
Yeah,
So
using
then,
this as a feature generating
yeah,
processing layer.
exactly.
Yeah, those are pretty weird features, but you can describe them. They're mathematically complex, but they're like linguistically, you can like describe what they are, you know, in a pretty simply, and that's kind of cool.
Yeah, I think that that's the thing that draws me towards this type of method, is that sometimes I feel like when I look at assessment algorithms, I'm like, okay, well, I can see how that particular feature set could work for a subset of students, but I'm not sure like how it actually functions for anybody outside of like one standard deviation on either side of each of the features, right? And this way of describing, we can tell the stories behind it. And it's a little bit more transparent what those stories might be. And I think that that's what kind of draws me towards it, is that layer of transparency in the way that we can talk about what it means to have a strong connection or a relatively weak connection for a particular user in a level. Depending on what our codes are, of course. Like those have to be equally transparent in order for it to work.
Yeah. Yeah, that's another use of thinking. Yeah, it's kind of into that spirit of like using these methods as part of an iterative approach, giving it more complex codes derived from other ways, and then having it create metrics that are used in other analyses. Yeah, that's good.
I want to be conscious that we're coming up on time, and I also don't know, Jen, when you need to actually catch your flight. But I kind of a question I had about like thinking about this as kind of like the conversation with the game. How does this work in like multiplayer? Does it just immediately translate, or like what if we have a conversation between players and the game?
It's probably more natural
which is often how I describe it anyways. Like you're conversing with the game generally, and then you're conversing with the other players. But it's just relations between codes and windows, right? So those, as long as those codes are defined in a multiplayer context, then it might get a little funky because a couple of these dots would be fundamentally connected because they'd be in like a same session together. But is that like the correct intuition?
Actually have where you're just plotting the your units are just your players, right? And so you don't actually even need a unit for the game per se. Your codes could relate to both player and game behavior and player behavior. The thing that I see as being the challenge there is something that goes back to what UW's currently working on, is that multimodal analysis. And what actually inspired multimodal ENA is that things like nursing simulations, the data that you're pulling out of the simulation itself is much more fine-grained than the conversations and the movements around the room that are happening. And so how do you find the weight to give the codes from the simulation as opposed to the codes from the discourse, so that you're not overly emphasizing one element or the other? And I could see that same challenge happening with games and multiplayer, that you'd want to find out what is the difference between trying to weight codes that are happening between players in discourse as opposed to what's happening in the game. And it might be that they have the same level of importance, and it might not. It's just going to be dependent on what the data is actually showing.
Cool.
Thanks for presenting, Jen. I've got to run like to something right on noon, but this was it was good to get the formal version of some of the thinking that I've heard you informally talking about. It seems really generative.
Yeah, thank you. And for anybody who's watching, feel free to ask questions in Slack or send me an email or message, whatever the case may be. Looking forward to seeing how this continues to develop over time.
Yeah, I think there's a lot of potential for Sims to show up in lots of different places.
Cool. I'll get the video
Alright,
posted soon.
Well, with that, we are at time. We will let Jen go catch her flight. And the various others of us. And so just final reminder, we'll be back here again in 2 weeks, where let me pull my schedule up, hopefully quickly. I can remind myself what that's going to be. Next 2 weeks, we will be hearing from Luc Paquette. Talking about STEM interest in a Minecraft simulation, I think. That should be interesting. And otherwise, we'll hear everybody on Slack.
See ya.
Yeah.